Hello everyone, in this video we're going to go over the solutions for the worksheet in week 11. So the first question is a question about graphing the curve that is given by a couple of parametric equations. If you notice, this is a very familiar type of curve. It's giving me x equals 3 sine of theta and y equals 3 cosine of theta. So this is essentially the circle of radius 3. It's much more easier to see this shape by eliminating the parameter, which is what is asking me in the second question. So it says eliminate the parameter and provide a Cartesian equation. Notice that when we square x and then we add the square of y, then what we're doing is giving you 3 sine of theta squared plus 3 cosine of theta square, and this is equivalent to 9 sine square plus 9 cosine square. Now I can factor out the 9, and if I factor out the 9, I get 9 cosine square plus sine square. And cosine square plus sine square is an identity which is equals to 1, so this is going to be equals to 9. So this means that this is x squared plus y squared equals 9. And so if we consider this being an r squared, this will be 3 squared. And so this means that this is the circle that is centered in 0 and it has radius 3. Okay, my graph is not the best here. So let's actually take a look using decimals. So if we use decimals, notice that x squared plus y squared equals 9, sorry, is going to give me precisely that circle of radius 3. On the other hand, if you would like to use some graphing tool like decimals to actually go ahead with the calculations, then you can also use decimals and write your equation in parametric forms. So I can say x is equals this and y is equals this. Okay. So let me see if I can make it read this as s comma y equals this. Let me just change the parameter here. Instead, let's define it in terms of d. See if that works better. Yeah. So now here I'm going to do 0 to 2 pi. And so now you can see that this is giving me the same circle as this. So they're doing exactly the same curve. Now let's go to doing some brief calculations. So question number 2 says, consider the curve given by the parametric curve x equals 3t squared minus 1, y equals t plus 6 when t is bigger than 0. And so it's asking me to graph the curve. So same thing as before. Let's actually do another one here, and I'm just gonna do So we have 3t squared minus 1. So 3t squared minus 1 comma t plus x. And this is saying that bigger than 0, so I'm going to go with 0 to, I don't know, 50. And so this is giving me now this curve over here. Okay. Now we want to find the equation to the tangent line. And so for the equation to the tangent line, we want to find, of course, a couple of things. We want to find a slope, and the slope is going to be given by the y dx at a certain point, because you got to be in a certain point. And of course, we got to have a point xy or x0, y0 that we're going to use for the tangent line to the curve. So let's actually go ahead and let's pick a number for that we can pick from here. You can pick any number in particular, but let's do t is equals 1. So if t is equals 1, then this point is going to be 3 minus 1, 2, and this is going to be 7. So the point is to 7, and then t equals 1. Now I need to find the slope, but the y dx is just going to be the ratio between the y dt, the x dt. So I just need to do the ratio between the derivatives of each of the functions. So the y dt is just going to be 1. That's going to be the derivative of t plus x. And the x dt is going to be 60. So that works out. And now the y dt, the y dx, when t is equals 1, is just going to be 1 over 6. So the equation of the line now becomes y minus 7 equals 1 over 6 x minus 2. Notice that if you change the point, then this is going to give you a different behavior. But so now for c, we want to find the first and the second derivative for this curve. We already got the first derivative from before. We have that the y dx is going to be 1 over 6t. And now for the second derivative, we can apply the formula that we have for the second derivative as the derivative with respect to x of the y dx, which is going to be equivalent to just the derivative with respect to the time of the y dx over the x dt. Now, this means then that this is going to be the derivative of the y dx, which is 1 over 6t. So the derivative of 1 over 6t over actually the x dt, which is 6t. And so the derivative of this, of course, is something that can be done by quotient rule. But this really is going to give me minus 1 over 6 t squared. And over here, we're going to have 60 divided. So at the very end of the day, for number C, the answer here is going to be minus 1 over 6 t over 36 t cubed. And so that's the end of the worksheet for week 11.